Welcome back, kiddos. We're looking at models of atomic structure, and I'd like to do an example with niobium. It gets us into a nice D sub-level, and I just like niobium. It's just a pretty name for an element. Now, let's take a look at how we would fill up an orbital diagram. Now, I've got an orbital diagram showing the potential energy going from down to up. You can certainly do this left to right if you want to in homework and that type of thing, or in learning opportunities that we'll be doing. It just simplifies. It doesn't take up as much space. So I have 41 electrons. Aufbau tells me to start with the lowest energy. The Pauling exclusion principle says do spins opposite. Aufbau says to go to the next lowest energy. Pauling says go spins opposite. Now, Hund's rule, remember, says put them in unpaired within a sublevel before you pair them. So I've done 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now notice I go to 4s before 3d. So 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now 4p. 31, 32, 33, 34, 35, 36. The periodic table shows you this. 37, 38, 39, 40, 41. So that shows niobium. Honestly, all of the good information is in that outer sublevel. Now, the questions that might be addressed with this is how many unpaired electrons are there? Because unpaired electrons, remember, structure, it's going to determine how it's going to function. In bonding, or in this case, a question is often, will it be attracted to a magnet? So there are 3 unpaired electrons, if I counted everything correctly, and I'm sure you'll tell me in class if I blew it. Let's double check. 2, 4, 6, 8, 10. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 39, 40, 41. We did it. Okay. So it is paramagnetic. Whenever there is 1 or more unpaired electrons, it's considered to be paramagnetic. Okay. So that's how you do the orbital diagrams. Now let's go to, I popped in a periodic table here to help us with the electron configuration. Do you notice in yours you have a nice little box? You may have to write small, but I tried to streamline it for you. You have a box to put your electron configuration in. I'm going to do it up here so you can see my periodic table at the same time. So we always start back home in our walk. So it's going to be, let me start over a little further. I think that's going to not be enough room there. You need a lot of room for these if you're going to have to do the whole one. So 1s, 2. Now, a lot of people want to put a comma there. We don't need any commas. Once we finish 1s, we come back here. We're in the S S block, second period, so it's 2s, and we can only have 2 electrons. Cross the ravine to 2p. There's 1, 2, 3, 4, 5, 6. So if you ever forget how many electrons are in a sublevel, just count the blocks. The periodic table gives you that information. If you wanted to know how many orbitals, if you have 6 electrons, there's 2 electrons per orbital, so that means you have 3p orbitals. Okay, so back to this. We do 3s, 2 electrons, needs 1 orbital. Cross the ravine, 3p6. Then I'm going to do 4s2 here, then into 3d. Remember, we drop down for our energy level. 3d, we're going to go all the way through. It's like that little kids on a trip. Are we there yet? Are we there yet? Are we there yet? No, we're not. 3d10. Then to 4p6, wrap around to 5s2. Now we're going to go into the 4d. Remember, if it's period 5, the energy level for the D block is 1 less. 4d, and we're going to go in 1, 2, 3. So it's 4d3. So that's how you would do the electron configuration. Now, I want to just peek on my next page and see what's next for our models. It says, write the noble gas shorthand notation. So let's come back up here. And what we want to be looking at is the noble gas that is prior to. So go backwards till you hit the first noble gas, and it's krypton. So what that's saying is all of this is the same thing as krypton. So I'm going to put brackets in krypton, and then I'm going to follow it up with 5s2 4d3. So that's how you would write the shorthand notation. Now your next one is write the electron configuration for niobium plus 2. So let's come back here to our previous page. So I want to find the plus 2 notation for this. So if I have a plus, well, Dina, if I have a plus 2 oxidation number, that means you lose 2 electrons. So now I have 2 more protons than I have electrons. So I've lost 2 electrons. Remember, we always lose our outer S and P first. So to do the configuration, you lose those 5s2 electrons. So you would write this whole configuration without the 5s2. I'll go ahead and do that to you. You have a little block to do it in. I'll try to do it to you. I haven't had enough coffee, I guess. 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Now I've lost those 5s2, so it's 4d3. Okay, now let's take a look at the next box. Says write what the electron configuration would be for niobium plus 5. So now to do niobium plus 5, remember you first lose your outer S. We don't have any outer P, right? Because we would have to have 5p to do this. So first we lose the S. Now we're going to lose those d electrons finally. And so we're going to lose those d electrons this time. And so the configuration would be just like the one above, but without those d electrons. Okay? So that shows you how we would do ion ones. Now, the last thing to do is to draw that shell diagram, that lovely shell diagram that I don't totally love, but I fear you will see. And so to do that, I need to take a look at how many electrons were in each energy level. So I'm going to start here, and let me erase that again and bring back our original full electron configuration. So we would have had 4p6, then 5s2, and then 4d3. So to do a shell diagram, we have to know how many electrons are in each energy level. So in energy level, whoops, sorry about that. In energy level 1, we have 2 electrons. In energy level 2, we have 8 electrons. That's the maximum it can have. Remember, 2n squared is our number of electrons. In energy level 3, we have 18. 2 plus 6 plus 10 electrons is 18. In energy level 4, we have 2, 8, 9, 10, 11. And then in energy level 5, we have 2 electrons. Okay? Now, a way that we draw this, and the IB really likes this, is they would write 2.8, 0.18, 0.11, 0.2. So that's how they would draw that. So it would be 2 for energy level 1, 8 electrons in energy level 2, 18 in energy level 3, 11 in energy level 4, and then 2 in energy level 5. So that's a very streamlined notation that really doesn't tell us much at all. So let's go on and let me show you what that looks like in the shell model. You know what? I want you to do this. I'm not going to waste your time on this because I think you get the idea. Make sure you draw this. Make sure you show your energy levels converging. So show me that they converge. All right. And then make sure that you show me that there are 2 electrons in the first, 8 dots for electrons in the second, 18 dots, or you can use X's if you want, and then 11, and then dot 2. And I will expect to see this on the notes check.